Hello everyone, this is Mitch Maddox, and for this tutorial I'm going to show you how to identify different types of data distributions with dot plots, which we also sometimes call line plots. So these are interchangeable names, so it could be called a dot plot or line plot, and all it is a number line with a whole bunch of X's or maybe dots representing a data set that you had in a list. And so basically, like if I, for example, show you this one right here, this just means I had a data set with 1, 2, with 2 3s, 4 4s, 2 5s, and 1 6. So now what a data distribution is, it's just how the data is shaped. And these are 3 ideal cases. These are like the perfect examples for the names that I'm going to give them. And even if your data set doesn't look exactly like them, you usually have to name your data set based on the one that closely matches it. So don't worry if yours doesn't look exactly like these, okay? So I'm going to start in the middle one because this is the easiest. So the way I like to kind of look at the distributions, I like to draw a curve that goes around the X's or the dots, depending on which one you use. And for example, I'm going to do that right now. I'm going to draw kind of like a mountain. I like to think of it as a mountain. And it kind of just follows closely to the X's. So if you look at this middle distribution, I notice that there's a peak in the middle with the 4 X's. So a peak again is just the highest point. And then you notice as you go to the next 2 around it, the 3 and the 5, there's 2 data points. And then you go to the 2 and the 6, there's 1 data point. It is symmetrical. We call this a symmetrical data distribution. So symmetrical data distribution. So it's because it's symmetrical. If I was to put a line in the middle, it's exactly symmetrical. So it's like if I drew a shape like a square on a piece of paper and I folded it in half, they will perfectly align as long as my square is equal dimensions. It's the same thing with this. This is if I folded this in half, they should overlap exactly. Again, maybe you have 1 extra data point on one side, but it generally follows this rule and it looks kind of like this, then it's still symmetrical. You can think of it like yourself as well. We are almost mirror images of ourselves. If you put a line down us as humans, you look at both of my eyes, they as a mirror, they're almost symmetrical. We're almost identical symmetrical copies. So that's what symmetrical is. Now let's go to the left one. Now I'm going to do my mountain again, and this time if you notice I am going downhill when I go to the right. So this is kind of like a downward slope, and so if you notice most of my data is to the left. So you have to remember to the left, most of my data is to the left. So but it peters out or the data starts disappearing to the right. So that means that this is called a right skew distribution. Or, no, sorry, I said that backwards. It is a skewed right distribution. I call this a skewed right. So you got to be very careful when you're doing this, because sometimes you can get confused by your directions. When it's skewed right, most of the data is to the left, and it starts dying out, or I like to say the data starts disappearing to the right. So that's how you can think of it. Now, if we go to the far right one, this is the same kind of instance, but instead I'm going to go uphill to my right. And now I have another mountain. This is instead the opposite. It's called skewed left. This is my skewed left data distribution. And so this one is just the opposite case. So it just means that if I have all my data to the right of my plot, and I see that it's starting to peter out or it's starting to disappear, my data starting to go away on this side, it is a left or skewed left distribution. Now there's one more type of distribution you may commonly see. It's called a uniform distribution. Let me draw it. So I'm going to draw it on the bottom. So a uniform distribution, it's just uniform. So the way I like to think of it is if I'm going to school and I'm wearing my uniform, I want it to look really, really nice. I don't want there to be any flaws. I want my suit or my uniform to look symmetrical. So it's not necessarily symmetrical. Sorry, I didn't mean to use that. But it's uniform. If you look at all the data points in this data set, they are all the same height. So this is called a uniform distribution. I'm going to do green. So I call this my uniform data distribution. And that is the last type. Now, just so you know in the future, if I have a data distribution that looks nothing like these, you just have to pick the one that looks closest. So let me give you one example. I'm just going to move on over here and make a new one really quick. So let's say I have some of my data here, and then I have the majority of my data here. So majority of my data here. So if you look here, I have a gap in my data. even though it has a gap, I can still try to explain the data distribution by picking one that best matches it. So if I did the mountain kind of again, I like to think of it as the mountain. I just kind of closely follow my x's. And you notice most of my data starts petering out to the left. So because it's petering out to the left, and most of my data is to the right, this should be skewed to the left. So let me double check. So, skewed left. So that's correct. This should be skewed left. And that is an example of how to do data distribution, skewed left. So I hope that helped, and have a great day.